We will go over how to make a solid sign in MecaWind. A sign is considered to be solid if the openings in the sign make up 30% or less of the gross area. If the openings are greater than 30%, then the sign would be considered open. To create a solid sign, click the Structure Type button in the General tab and select Solid Sign. We must now select a MWFRS analysis method. The only valid option for a solid sign is Chapter 29. There is no component and cladding method for a solid sign, and so we click the C and C method and select None. Now we have to determine if the sign is flexible or rigid. If it has a natural frequency of less than 1 Hz, then it would be considered flexible, otherwise it would be rigid. We will assume the sign is rigid for this example. Now click the Solid Sign tab, and we will see the inputs required for the solid sign. The first option is a Help button, and this help provides some diagrams that may be useful in understanding the inputs. Height from the grade is how high the sign is from the ground floor to the top of the sign. Next, we specify the height of the sign itself. If the sign goes all the way to grade, then this dimension will be the same as the first height which was entered. If the sign is elevated, then we only enter the height of the sign itself without including the distance from the bottom of the sign to grade. Now we enter the width of the sign. The thickness or depth of the sign is then specified. If the sign has a return corner that protrudes perpendicular to the sign itself, then that is specified as a return corner. Please refer to the help for an illustration on the return corner. If no return corner is present, then enter 0. Next, we specify the solidity of the sign. If the sign is completely solid without any openings, then you would specify a solidity of 1, which would indicate that the sign is 100% solid. If the sign is comprised of 30% openings, then a solidity of 0.7 would be specified, indicating that the sign is 70% solid. If you try to specify a solidity of less than 0.7, then an error will be generated, because a solid sign must have no more than 30% openings in the gross area of the sign. If your sign is attached to a wall or building and not on support columns, then select Attached to Wall. The wall zone would then need to be specified because that will affect the wind loads. If the sign is near the corner of the building, then specify the corner zone of 5, otherwise use Zone 4. Please refer to ASCE 7 for the specific dimensions that determine when the building transitions from Zone 5 to 4. If uncertain, use Zone 5 to be more conservative. If your sign is double-sided and enclosed, then check that option. If our sign is located on columns, we will select Supported on Columns. We can specify the size of the columns and the spacing, assuming there is more than one column. If there is more than one column, you may also specify if the columns are offset so that they are not symmetrical. If they are symmetrical and centered, then we specify that the offset is 0. We also select the shape of the column, which is used to calculate the aerodynamic shape factor. Now click Perform Analysis in the lower right corner, and the wind calculations for the sign and supporting columns can be viewed. The solid sign could be used for other structures that are not necessarily signs but might be rectangular and less than 30% openings. For example, let's say you have a structural frame that is supporting equipment, piping, platforms, etc. When you look at it, if it is effectively solid, then you might use the solid sign to calculate the total wind load on the structure and the objects it supports combined. With a little imagination, you can find that there may be many non-sign structures where the sign criteria might be useful.